All right, good morning, everybody. Welcome to AWE 2022, Day 3. We've got a great program for you today. My name is Lance Anderson. I'm the VP of Solutions for CareAR. Many of you probably know me from a few other company names. This is actually my 10th AWE. I made it to double digits. I guess that makes me old, I don't know, but really happy to be here. And so before we get started, I got a couple of things I got to take care of. First of all, obviously, none of this happens without our sponsors. So let me thank our gold sponsors, ArborXR, HoloLight, HP, Meta, Niantic, CareAR, Metadome, Snap, TikTok, Soar, and Metamaterials. Love those folks. If you haven't been out to the expo floor, which by the way is open today from 10 a.m. to 3 p.m., check everybody out. And of course our titanium sponsors, the big dogs here, Avatar, Magic Leap, Qualcomm, and Unity. Make sure you go out and check them all out. A couple of little housekeeping things. It's day 3, so I hope you've downloaded AWE Live and you have that app for your agenda, for connecting with folks. If you're on social, hashtag AWE 2022, please follow us along. Coffee breaks sponsored by CareAR starting at 10 a.m. Make sure you stay well caffeinated here. But so, get things kicked off today. We have a great start to the show. So coming up on the stage here is Antti Sunnari. He's the CEO and co-founder of Dispelix, and he will be talking about waveguides and the manufacturing. So let's have a warm welcome for Antti, please.
Okay, good morning everyone. Great to be here on behalf of Dispelix and telling you about waveguides. So first couple of words about Dispelix. So our company was founded 2015. We are currently 120 employees, growing fast. We are based in Finland, US and China. Finland is our headquarters. And up to date, we have raised $50 million. On what we do in Dispelix, so our waveguides are so-called surface relief gratings, not holograms. The internal, what we do, we have an in-house design software running in supercomputers to simulate and optimize the waveguide structure. We have an in-house proof of concept manufacturing. So after the design, we can have already prototype in a matter of 4 weeks. And also a small line to manufacture in small quantities these waveguides. And then we have a mass manufacturing team to work with our partners. The public partners are AAC Technology and Applied Materials. So little bit diving more before going into details. So what we do, we use really high refractive index wafers, the highest in the market, 2.0. It relies on this numerical optimization of the nanostructures. We have LED and laser products going on. Today we have more than 60 patents. I think it's 64 or 65 currently, plus 200 applications. And we have tons of PhDs, so really a deep tech and to master these waveguides. So these are like examples of our 2 products. So on the one with the text, that's on the laser one. And we can see that there is a lot of things in the products. There is batteries, image processing, connectivity, and so forth. And of course, there needs to be a projector. But we as a company, Dispelix, we are only focused on the waveguide part, so the lens that you are looking through. And on the other hand, there is the product for the LED illumination. So it works on the LCOS, DLP, micro LED displays. And we as a company, we have been focusing on the consumer end, so consumer products. And that's why the form factor is really important for us. So, but we can only do the waveguide. Our customers needs to make the end product. and we just made really cool marketing video. I'm going to play next, where we hope that our customers will make a product to help people's everyday life when they are commuting or construction or anything. So let's look at a really cool video. Okay, that was a really cool video. I like it a lot. So we have been known as Dispelix as being a single layer waveguides, and many people always ask how we do it. And you know, big part is the software that we master the simulation and optimize the waveguide structure. But this time I'm going to talk about how we manufacture these and compare a little bit on the traditional way of manufacturing waveguides. So first of all, this is from Bernard Gray's FireChat slides that he gave just a few weeks or a month ago. So we have a different variety of waveguides. So we have an injection molding, Letin AR, Epson 2s there. We have a non-contact optical copy, basically laser interferometry many times, and that's Digilens imaging optics. We have cutting, gluing, coating, Aurum, and Lumus. And I don't know anything about how those are manufactured, like details, so I'm not going to talk about those. But what I know in the surface relief gratings, there is two ways. There is a nano imprinting lithography, and there is a direct etch on the manufacture these waveguides. So let's go through a couple of points on those methods. First of all, what is essential the surface relief waveguide manufacturing? It's a pattern transfer on the glass. Well, that's to put it in a simple way. But we can easily divide it in three different things. So first of all, we have the materials, like a glass, wafers, resins, coatings, all of those. Then we have a front-end process, which is actually to form the nanogratings on the glass wafer. And lastly, we have a back end, so when you simulate those and have a couple of coatings there more. So I'm going to focus on the front-end process because other things are quite similar on if you manufacture by nano imprinting or direct etching. So in the nano imprinting lithography, once again oversimplified, you make a waveguide design, and then from the waveguide design you make a master that is made on silicon or quartz. Using usually E-beam, can be used other tools, but usually it's the E-beam. From the master you make a polymer stamp, and the polymer stamp is used for the patterning. And if you think about the process step, you have the glass, then you have a resin coating. You can do it by spin coating or inkjet. After that is the pressing of the stamp in contact with the resin, and then detaching that stamp. Before detaching the stamp, you cure it with the UV or heat, okay, and the pattern is transferred. This is really simple and a nice way to do. And you have a lot of partners there, so you can have tools from EVG, Skill, German Litho, a lot of companies there. There are resins available from many companies. You can have NTT, Mitsubishi, Incron, microresist technology. You can have an easy access to start the work in the research institutes, universities, and tool manufacturers. And you even have like foundries companies that are using this technology, like an AMS, Applied Materials, Cyvax, Hymax, Visera, etc., just to say few of those. So we do it more complex, the waveguide. So first of all, we have a grading layer that is an inorganic material. We usually get these wafers with coated already with that inorganic layer. Then we do a resin coating, spin coating or something, usually spin coating. Then we transfer the pattern in that resin. We can still use the nano imprinting lithography, but we can use DUV or we can use Talbot lithography on that one also. And after the patterning, we etch down the structures and then strip the resins. Okay, it's way more complicated than nano imprinting lithography and have more process steps, but there is a reason why we do it that way. And let's go on those main reasons. First of all is the reliability. So you have to pass the same reliabilities as a mobile phones, laptops, and those. And then plus you have the mechanical safety because it's an eyewear. I'm not going to focus on the mechanical safety in this talk because it's a drop ball test and that's easy solved by a plastic cover lens. But what test you have to go, it's like 240 degrees, 240 hours, 85 degrees Celsius, then 240 hours at -40. That's called also Finnish winter. And then you have to go cycling of that, so cycling between those. And that's really hard on the polymer materials to pass those. Then you have a moisture, so in a 25, 55 degrees Celsius, ramping different temperatures between those temperatures and changing the moisture all the time. And the last is the UV, so a dose of 10 kilowatt hours per square meter is given to the lens. And that's really hard for the resins that have photocatalytic fillers like nanoparticles, like titanium oxide or other oxides which are photocatalytic usual. I know that our waveguides and our gratings can survive these. We haven't been testing on the nano imprinted, but I doubt that a little bit. Another thing is the field of view. So we do the pupil replication, like 2D pupil replication here on the first picture. The second one is the donut and what we called the vector space. And now how thick that actually that donut is, it depends on the wafer refractive index. So higher the index, you can have a bigger box inside, which means you have a larger field of view. And now we can see here, like in a simple case, if you have 4:3 aspect ratio field of view. So in the 2.0 wafer index, you can have a 40 degrees field of view, diagonal field of view for RGB. And if you do a monochromatic, you are close to 70 degrees field of view. So when we do an etching, we are not limited on the resin refractive index. So we can go to 2.0, we can go to up to 2.7. So we can Actually the limiting field of view on a single layer for us is the glass index. But when you do it by nano imprinting, then the limiting step is actually the resin refractive index. And if you use 1.8 resin, you actually end up having like 30 degrees field of view. So one reason we use an etching method is to have large field of view RGB in a single layer. Many could think that actually you are limiting on the nano imprinting, you can make any kind of structures, but actually you can do the same structures in etching. So we can do 2D gratings, pillars, holes. We have done those. We can do slanted structures. We can do those binary structures, of course, and place structures. So etching is not affecting on the selection of the nanostructures that we can, or the shape of the nanostructures that we can make. On a yield in etching, so usually when you have more process steps, it actually means that you have a poor yield because that's pure mathematics. But there are a couple of things to look on this. So first of all, in the nano imprinting, if you have a 1 micron particle, you put the polymer stamp there, it forms like a dent there. So one micron particle becomes 10 micron particle, and that's a scrap when it happens. Periodicity is really important on a waveguide. That's how it's done, and that's you easily lose it on the plastic stamp. It starts to stretch, and then you lose MTF, and then it's in the contact. So you have to remove it after curing. So there is an errors also, and especially if you have a lockdown structures like a slanted structures, it's really hard. So on etching, how we do it, it's not only on nano imprinting lithography. So we can use contactless lithography like deep UV, Talbot, which the yield is really high. It's like optical lithography. So if we happen to have 1 micron particle, it remains to be a 1 micron defect, and that's usually not a problem on a waveguides. Periodicity remains. It's very mature technology, like your phones and the semiconductor chips in your phones and tablets and everywhere are made on this method. But of course, we can use an nano imprinting lithography for a patent transfer. Then everyone is saying the manufacturing cost. Well, I might be a little bit honest on this one and saying that on the smaller field of view, where we are thinking about 20 or 30 degrees field of view, you can do it in a single layer using resins and a direct nano imprinting lithography. But when you go above and you want to have like 40 degrees field of view in a single layer, there it is when it kicks off with the etching. So when the field of view is small, then nano imprinting lithography is okay, and the larger field of views, you go with the 40 degree, with the etching method. But that's only for the field of view and manufacturing cost. Then grating response. So if we think about this donut here in the center, so you have a in-coupler pushing it downwards, then EBE structure push it on the upright, and then the OC is putting it back. So this is a case if you have 60 degrees diagonal field of view, 16 to 9, and you have 2.0 material. So this is a green only. And now what happens when the field of view increases, that the jump length in the waveguide, so when light travels by total internal reflection, the jump length gets longer. And now when you have higher index in your material, it actually means that it works better with those field of views and larger field of view compared to small refractive index materials. Then it opens also more design freedom. So Usually on a nano imprinting lithography, you might have like the resin nano imprinted and then ALD coating or something on top of that. But this etching, we can have really much different materials, like a stack of 4 materials or something, and that gives a benefit on the waveguide design end, especially when you do the hard way on a single layer and full color. Do I have still slides? I have a mapping here, yes. So if we think about nil versus etching, so on the reliability, it's really reliable on way of manufacturing because it's inorganic on top of inorganic. Field of view, you can achieve a larger field of view in etching. Creating shape, we have the both shapes that we can use. On a yield, I would say that the etching is really mature technology. So the yield is better on etching. And the manufacturing cost, well, depending, yeah, I maybe not totally fair here to say, but it should be green to both. But when it's the larger field of view, it's etching. Design freedom, you don't have a lot of design freedom on a waveguide design in nano imprinting, but more on the etching. And then the manufacturing options, we can go into TSMC fab and make these waveguides there, basically. And I rest there. Okay. Thank you, everyone.
Okay, welcome back, everybody. Got a great next panel for you called the X-Verse. So I'm going to introduce our moderator today. Her name is Tish Shute. She's actually the co-founder of Augmented World Expo back in the day with Ori, and she's also the director of spatial computing at Futurewei Technologies. And without further ado, I'm going to let Tish come on up and announce the rest of our panelists. Here we go. Welcome.
Now? Yes. Good morning, everybody, and welcome to AWE 2022 and the X-Verse panel. The panelists are coming on this stage. They are going to introduce themselves and some of their amazing work shortly, so I will just introduce the theme of this panel and a little mention of why we called it the X-Verse panel. As you know, the Metaverse word is on the tip of everyone's tongues. But unfortunately, it seems to have forgotten a little bit about the big vision of the augmented world, where reality is the platform for computing. And we're a little trapped in this idea of interoperable VR worlds. So every panelist here has a very important vision. And it takes us back to the fact that this metaverse definition is too narrow in the way we're thinking, and it's perhaps missing the most important aspect of this paradigm shift in computing, where we shift from the information being the platform for computing to the real world. And I know the title, The X-Verse, conjures the idea of superpowers, but I think a theme that unites us all is if superpowers are indeed there to be had, they need to be accessible for all. So no further ado, Anselm, could you kick us off?
Hey there, thanks. I really appreciate the chance to be a part of this panel and to be here today. So I'm a longtime developer. I was at Park, Mozilla for a while. It's always hard to describe myself. I'm interested basically in helping people see better, see through walls, understand natural ecosystems, understand each other better. And it's kind of been my mantra in the work I'm doing. Let me just go ahead and roll into the first slide here. So what's interesting for me this year is that being part of this panel it's an interesting chance to talk about something that I see as something new this year. This is a very fresh year for AR. We see some of the largest companies in the world are starting to double down on the metaverse. We're seeing digital twin projects emerge, which I hadn't expected to see for years yet. We're seeing AR glasses hardware emerge, which is going to make some of our ideation around this technology much more accessible. And especially we're seeing 3D reconstruction and scanning, computer vision, and some of this technology, this machinery that connects the digital and the real together starting to occur. It was funny, I was in Venice recently and walking around and Google Maps said that, your location is inaccurate. We can help you improve that. And they're like, okay, and I push the button and it's like, hold up your phone. And it looks at the buildings and it actually pinpoints where I am, like down to the centimeter, and says which direction my gaze is looking at. It's just like you knew that stuff was coming, but for me to actually just have that on a commodity device and just walk around with it, it's just kind of bringing it all together in a really unusual way that it's funny because if you've been here earlier, many of us have watched this technology, but seeing it actually happen today is fascinating. But I think I have a little bit of a concern. I think we kind of bring our anxieties from Web 2 into Web 3, which is that we saw Web 2 captured by large players. And maybe not Web 3, but like the future web. I think what I'm interested in seeing in the future is how can we make sure that we allow open, democratic access, participation to this technology. So that's where I'm going to go with my quick intro here. So I would say that, first of all, what do we mean by, what kind of technologies are we imagining people are going to be using in the near-term future? I would have roughly 3 buckets. And I think we can all think about the kinds of apps we imagine are going to exist. But I'll just generally capture 3 kinds. I think the first thing that we want is sensing and sense-making tools. We want to be able to tell our digital agents that we're interested in knowing where our friends are, or we want notifications about events happening nearby. This is a kind of basic understanding we have and expectation of the world. I think on top of that, we're going to want to be able to mark up the world, obviously. The same way we can mark up a document, we want to mark up the real world with post-it notes or actionable verbs that you can push a virtual button and have it do an action, right? This is a kind of expectation I think that we have for the near-term future. But I think the most powerful thing, and the thing that's somewhat underrepresented, and if I have any hopes and fears about the future, is that are we going to be able to really program and create and share our ideas, that things that haven't been done yet, the new projects and new ideas, can we make those things and share them with our friends, extended people? You know, can we tell a small story? Maybe you personally had an experience walking under a cherry blossom tree and it showered you with cherry blossoms. You want to just make a little vignette that someone can experience. Can you make that and share it easily to your friends? You know, beyond just taking a picture of it or a video, can you share an interactive experience? And that realm of programming for me is really special. And not maybe because I'm a programmer, but I feel like that's something I want to give everybody as a power. So last year, I had a grant from Futurewei to explore building a future-oriented browser. And it's actually remarkably hard to write a browser. But what was interesting, the discovery wasn't what I thought. When I came out of that process, I realized that, oh, actually what it really is about how do you describe and share apps. If the web of the past was sharing text and images, the web of the future, I think, is sharing rich experiences. And perhaps, again, that's warped by me being kind of a technical person, but I feel like that's the power, that power of real creativity, real authorship. And so I guess I start to think about, you know, what kinds of you know, I think about the people that I really admire, and I think about the ways they think about the way they empower other people. If you look at Brett Victor's work and you look at Douglas Engelbart, they had a philosophically humanist perspective where they were interested in empowering others. And I think many of us on this panel here today share that sentiment, and it's one of the reasons I'm excited to be here, is to talk about these kinds of ideas. And to be a bit specific, just a tiny bit of a drill down, what do I mean by that? I mean that we have these amazing computer vision tools. Why can't I just grab one of those tools and plug it into a little app of my own and put a funny hat on all of my friends in a crowd as I'm walking around, you know? Or why can't I just like playfully explore ideas with these tools and grab that whole app and share it with somebody? And to do that, it looks like the future needs better definitions of what apps are. We need Lego-like tools, but I think we kind of need a conversation about our expectations of the future. And with that, I'll move on to you.
Awesome. Thank you, Anselm. Hi, everybody. My name is Stache Bagley. I am the CEO and founder of TechPlayzone in Tampa, Florida. TechPlayzone came up with educational STEM outreach in a way that we don't think had ever really been amplified before. We had some companies in the past called CompuKids, you know, where they sort of taught kids how to use computers. And we knew that young people were going to be very engaged. You know, now we call them digital natives, right? We knew they were going to be very engaged in technology, but there wasn't a real platform or a pedagogy for how we would engage students at a young age to make sure that lots of kids could pursue science, technology, engineering, and math. So TechPlayzone started with the idea of pre-K through third grade. We simply want to interest our kids. How can we give them a Lego-like toy, like Anselm said, that would allow them to build and to create? From fourth grade through seventh grade, we wanted to build that confidence, especially among our girls, especially among our underrepresented groups. We recognize that during those grades, that's when kids tend to see themselves as less able. And we know that all of them are capable with access and availability and a little bit of motivation and fun, right? Exactly. All of our kids are capable. So in those grades, we were building confidence. From there, we started talking to them about the pursuit of majors. Hey, you can be an engineer. You can be a computer scientist. Oh, you're interested in aeronautics? Oh, yeah, let's do that. And let's find the tools to engage the kids so that they are, at that point, confident and interested and ready to tackle all of those tough topics we know they're going to see in high school, the rigor that they're going to need in math and science in order to be productive. And on the post-secondary level, because TechPlayzone has sort of taken me to the next level, and I've had an international platform to share that instead of just giving our students lectures 3 hours a week and asking them to understand complicated differential equations and discrete math, why can't we actually put some tools into the college classrooms where students will understand the actual concepts? And so I'll talk more about that in just a second. But we at TechPlayzone use robots as a hook. We use the Lego Mindstorms that Mitch Resnick and Seymour Papert talked about years ago, about how we can engage kids in coding. And just from that interest, you would be surprised that the young people then take it on to the next level, science experiments. They want to do their own research. They want to think about how they can change the world using robots. And you guys know where I'm going with this. I want to do competitions. If we can do it with FIRST Robotics, which I've been a part of now for 17 years, then we can do it with the X-Verse. We can have K through 12 competitions where our students are designing and building and creating and coming up with their own ideas as creators versus simply being consumers. And what do we need for that? We need to make sure we connect the complex topics to the actual hands-on tools. And we've done it with robotics. I'm not going to go through that whole slide, but I know that we can do it within the X-Verse as well. So TechPlayzone started. You know, I have a computer science degree, but I promise you I know nothing about Unity. Can't do Unity to save my life. But I started with some tools that were on hand. And what was on hand for me was Verbella. And we started there with having a robotics competition for over 500 students, 100 volunteers, 200 coaches, all inside the Metaverse, right? Showing off their robots, their coding, and their competitive spirits. And of course, competition breeds innovation, especially when done in a nice, compactful way. So of course, prior to COVID, we were doing Tinkercad, we were making our 3D models, we were having great fun with the, you guys remember the Viewmaster, where you stick your cell phone inside the Viewmaster and then you could see virtual reality feels. So we were doing that. But COVID, of course, is a catalyst for quite a few things. And once COVID hit, TechPlayzone had to bring the kids into the X-Verse. We used Frame VR for that. Frame VR at this point, and we call it Frame. Frame at this point is the one platform that I've seen that really combines computer science, 3D modeling, imaging, and even now with GPT, being able to speak a world into existence just by saying, bring in the moon, bring in some stars, let's have a gravity that's what it would be on if we were on the moon. Frame does that for our young people, and it allows them to create. So we're doing the exact same thing, and I want you guys to do it as well. I want you to teach them computer-aided design, teach them game mechanics, help them understand physics engine and how it works in the games that they're playing. Let's make trigonometry and linear algebra not as complicated or confusing as it is now, you know, as far as weed out courses, and allow it to be catalyst. And kids are like, oh yeah, we understand now why we actually need to know this stuff. Because what's the #1 question? When am I ever going to use this, right? That's the #1 question. So of course, HTML, JavaScript, and WebXR, and it brings us into artificial intelligence and machine learning. And so that's what we're doing at TechPlayzone. That's what we expect to happen. I wholeheartedly think that Ori should have an Educational Outreach Augie Award next year. Yeah, there should be something for people who are reaching out to those young people and helping them to be creators. And where are the competitions? I mean, I understand a $100,000 prize for eco-friendly climate control, but our kids don't need $100,000. They simply need something that says they can create and build a world all of their own. So again, I'm Stache Bagley. I'm the CEO and founder of TechPlayzone. Feel free to connect with me. I'd love to talk about this more. And I'm going to hand this over. I want to say it's going to, yeah, David. Augie winner David, y'all. Yes.
Let's see if this works. Hey, it worked. So it's really interesting that this discussion so far just completely overlaps with our vision at Croquet. In particular, we go back in time to Doug Engelbart as kind of the touchstone for the person who said how the world should work. He understood that the computer was primarily a communication medium, a way of engaging with other people where this backbone of ability to do simulations and shared state and interactions, which, by the way, he was running on, he had his entire team running on one single time shared system, which made it possible. What happened was my mentor, Alan Kay, invented the personal computer at Xerox PARC. And of course, that system, even though they had email and they had ability to transfer files, they didn't have that same level of collaboration. That was extraordinarily unfortunate because it's sort of like the whole intent of these systems. Alan recognized the computer as a medium of conversation, and that got lost. So when we started thinking about how do we make that come back, and Alan and I had years of conversations about this, but we realized that there's a need for a system that enabled the same kinds of interactions and capabilities that Doug had demonstrated, by the way, in 1968, but he wrote about it in 1962. So that's what we're after here. It's like we realize there needs to be an operating system that enables that kind of collaboration all the way up and down. It's essentially, you can't layer in collaboration at the top. It has to be something that's foundational. Let's see, does this work? There. So we're building this operating system on the model of, actually everybody's come before us. Doug Engelbart, Alan Kay's Smalltalk system, you'll probably see hints of that here. You'll see hints of HyperCard, if you remember that. HyperCard was this sort of end user programming system, allowed you to construct systems dynamically. So we see the world, we see actually the web as the center of the metaverse for many, many reasons. One is the web is an extraordinarily powerful platform. It's friction-free, easy to share, easy to access. It's fast, getting way, way faster. It's just an amazing platform. And most important, every single device that has a screen has the web running on it. In other words, you think about someday you're going to be wearing a Meta device, I'll be wearing an Apple device. How do we communicate? Especially if I think that the metaverse is primarily a communication platform. How are we going to engage? How are we going to do that? And so the fact is all these devices have the web browser available. And the web is, as I said, extraordinarily powerful. This is our team who's actually been working with Alan and me for decades. This is an overview of the architecture of the system. I won't go too much into this, but basically that middle line, think of an operating system. Traditionally, also, it's the thing that connects to the hardware, but this is a real operating system. It just happens to be delivered via the browser when you run it. And part of it is local, and part of it is what we call an edge reflector. I'm not going to touch on that. I want to show you kind of what it really does. Oh, hold on, there we go. This is how the system works real quick. When you interact with the system, and you're going to see a quick run through. When you interact with the view, a message gets sent up to this edge reflector that has no state. So that gets sent up to a virtual computer. It's running on your system. It runs bit identical. But more fun is this. This is two users in the same space right now. And what I'm going to do is give you a tour, and I'm going to grab hold of the other person, bring them there. Everything inside here is multi-user from the top down. And it's not just a deployment platform, it's actually a development environment. This is a multi-user asteroids game, which is kind of a blast. This is a multi-user text editor. And one of the things to notice is just how fast this is. This is not eventual consistency like you see with Google Docs. Everything is instant. It's all about latency. This is a Bitcoin visualization app. There's actually 3 different cards stacked together. This one's really wild and really shows what we're talking about, the difference between an operating system and kind of traditional deployment. We just clicked on that flamingo, brought them down, but what's going on here, this is the code that's running that flamingo. And there's 2 users in here. I'm going to modify that code so that instead of moving forward, we're going backwards. And when we compile that, flamingo's flying backwards now. Every bar of the system is extensible. And if you're familiar with Smalltalk, you'll understand what I'm talking about, that it's modifiable. This is every single flight, every single commercial flight on the planet. And this is portals. Portals are going to be a central aspect of the metaverse. It's the whole point of being meta is that I can go from one world to another. One of the nice things about this is the worlds are iframes, so they're perfectly sandboxed. What's really going on, if you remember how Disney did animation with multiplane cameras, that's what's going on here. We're actually seeing an iframe on top of the iframe, and so you can actually see from one world to the other. And when you go from one world to the other, you actually just switch the iframes. So we have a beta available today. This is a quick and dirty advertisement. Try it out. It's actually kind of amazing. That's it.
How do you follow Dave Smith in Croquet? I'm Andrew Melchior. I have a background in the music industry, so the universal language of music. And it's interesting to think about interoperability because music is something without borders, and you either are naive and you learn it and teach yourself, or you have a prescribed way of learning it through notation and manuscript. And some of those continuums between what I do with music, I think, work very well as analogies to what's happening all the time with software and computers. There's another Dave Smith, unfortunately he's just passed away. He was a founder of a company called Sequential Circuits, and he was one of the reasons I've ended up doing what I'm doing. Now I've had the great fortune to work with some fairly luminary people in the music industry. In the late 90s, I was pulled in front of David Bowie at EMI to see how I could build websites that he would approve of. It's like, that was easy, obviously. And from that very great energy and power, and somebody who was very savvy around music and the internet, it inspired me to carry on and work with similar artists who are equipped in a similar way, who are adventurous and willing to work with technology to try and increase the engagement of their fans, to tell the story of their ideals and concepts as musicians. So whilst at EMI, I also got to work with Sir George Martin, and he was the clever guy at EMI who put a bunch of guys with lab coats and clipboards in front of 4 very stoned Liverpudlians to see what they would come up with in a world of Thorn EMI and what engineering could do for their music. And lo and behold, they strapped 2 4-tracks together and recorded a multi-track recording of Strawberry Fields and changed music forever. Yeah. So he was very inspirational to me, Sir George. And then the pathways moved to people like Robert Del Naja from Massive Attack and Björk, and also Marina Abramovic, all performers and artists I've been very fortunate to work with, who are using technology daily, who are trying to find ways of communicating their ambitions, ideas, and artistic ideas in new ways. So to be amongst these very amazing group of individuals, I'm quite humbled because I feel like, from my perspective, especially with the metaverse idea, is that there needs to be a creative consent. You need to figure out why you're doing it and what is the call to action. Well, music and art is a good thing to do. Saving the planet is a good thing to do. We had a conversation before I came out about the original purpose of the internet, and that was ARPANET. So that was the idea that if there was ever, perish the thought, some kind of cataclysmic event, the computers would still be able to heal in a network and carry on communicating. So my angle for this conversation in particular is the why, and also how we can populate it with art and beauty and make it a place you want to be, but also how can you make it interoperable. So back to Dave Smith, the other Dave Smith, who's unfortunately just passed away, he invented a thing called MIDI. And MIDI is a machine language that is formulated to allow anybody who adopts the MIDI standard to plug it into their electronic instrument, and for all those instruments to be able to communicate in a binary fashion with a formulated standard that's international. And that's been going on since the 80s. And I feel like that narrative is definitely something we want to try and find for the metaverse. It's find the codex, find the standards. So just to summarize where I am right now, is I've started working with a company called The Mill. And The Mill was founded in 1990. It's a British success story in visual effects. It's one of the first real powerhouses in the UK to do visual effects. I'm now the global director of The Mill Experience Division. And I have about 50-ish people around the planet who are trying to manifest the physical hard point of digital effects and VFX into experiential marketing and also pastimes for people who go to galleries, museums and things. I think that the reason I'm bringing that up is because I think where we are with regards to what the Mill can do is we're looking at populating these worlds. Ostensibly, you have a lot of bandwidth, you have a lot of ambition and desire, But I run a team now of multidisciplinary people who are, again, all smarter and younger than me and better looking than me, who are able to think about the metaverse in a way where we're trying to find ways to move between augmented reality, physical theater, using sound, using vision, using haptics, and all the good stuff that happens at Augmented World Expo. So I'm like a kid in a candy shop here. To basically enable and to see what the vision could be for filling this metaverse with beautiful objects that speak to one another. You can all sort of go to the Mill website and figure out what's going on with us. I mean, I don't want to bore you with lots of slides with tiny print on them. But in essence, it's great to be here and to have the opportunity to talk to these luminaries. Cheers, Tish.
Thank you. Well, we're going to just start some discussion with the panel, and I actually would like to start on this theme that you brought up, which is, this technology needs to be purposeful. Technology needs artists, actually, is a phrase I saw on the Mill website, but it needs to be purposeful. And maybe just a quick riff on that, Andrew, and maybe I'd like to go down the line before I do some individual questions on that topic.
Yeah, I mean, the why is very interesting. So working with artists, as I've been very fortunate to do, you have a track based around an objective. So it's an album that tells a story, or it's a narrative framework that's been created by the artist. So there's a reason to engage. And I think beyond vignettes of smart tech demos and things that are plausible, I think it's very important to have a consistent artistic approach to creating the value in technology, I think, in some ways.
Yes, and this is, I know, Desh, you could actually take this away for the next hour, but you mentioned something very critical when we were discussing it earlier, and that it's really, why do we not have a small talk for this space yet, or Lego Mindstorms? And, I think it's such an important point. That might have been the first thing.
Well, because this is what employers come to realize. If they don't start thinking, what does the education look like to build our future employees, that's why it matters, really. You have to think to yourself, how are we going to engage the next generation in the Xverse while they're young, so that they will want to come up with the innovative and creative ideas that our companies will need. So the why for me is always, how can we make sure that we're not leaving anybody behind? We have multiple voices, and when the metaverse does have clothing, the clothing looks like more than jeans and a t-shirt. How can we have various voices at the table and get more people involved? And that's the why for me.
And just to Anselm, Alan Kay is really the great visionary, I think, that all of us kind of trace some of our thinking back to. And he has a phrase that he uses, computing for children of all ages. And it's something that, I mean, David's point out that he showed demos of what this should be like. And yet, here we are, still, you're working on this, in fact.
Yeah, it's funny, I was just reminded, there's a friend of mine, Wendy Brower, she has a project called Green Maps, and they're very interested in just doing maps, community maps. And she said something that always stuck with me, which is that she would have kids draw with crayons if that's what it took to make maps. She just wanted to empower people, right? And the interesting thing about when you empower creatives, kids, artists, is you don't want to be between them and the medium, right? Like if you're between the artist and the paper, you're basically like the paintbrush, and it's very frustrating. It's not a pleasant place to be. If you have to be the person that types in the code or mediates their creativity, it's painful. And so kind of like, it's almost like a fear response for me. It's like, I just want to give them power and then just back slowly away. Like just, it's almost because they're going to do it anyway, and if you don't help them do it, it's just a world of pain.
Yeah, so. Yeah, and I think, just to sort of bring this back to that huge topic I brought up at the beginning, in terms of this shift to real-world computing, I mean, it's something that's not mentioned enough. It's all based on devices that see the world. And it sort of brings machines and humans together in this new relationship. And that's something we really have to think about, that this technology we all talk about is fundamentally changing human to machine to human communication. And again, an Alan Kay phrase, when we change the means of communication, we change what it means to be human. So segue to David, because I know we've talked about this lots.
I have a very I have a perspective about what the metaverse is, and I see it primarily and powerfully as a next communication platform. It's basically, it's going to enable what I call an augmented conversation where you are talking to somebody. The computer AI is a full participant in that conversation. So when you say something, the computer is going to generate a shared simulation that both of you can engage with. I mean, what you saw was a little bit of that. But the idea then is, hey, you and I are in the same experiential place exploring complex ideas. This is, by the way, it's not the new idea. This is first described by Doug Engelbart in 1962 in this concept that he had enhancing human intellect. And the way he thought of it was just that same way, as a conversational system where we're exploring ideas, exploring information. And so what you're really going to be doing in the very near future, when we have these glasses or whatever, you're going to go walk to somebody and you're going to say something and it's immediately going to be reified. That idea is going to be instantly shared. And one of the things that's really important is that you're defined more by how you communicate than anything. It's the way you think. It's sort of the operating system of your brain is the languages you're working with. It could be music, it could be language, it could be mathematics, or it could be English. And what happens there is that if you're defined by how you communicate, and we expand the bandwidth of how we communicate, the language expands, the nature of how you communicate, you're redefining yourself. And you're redefining what humanity is. That's what the next opportunity here is, and why it's so important to get it right. Because if you don't own your world, you don't own your words, your meta words, we're in trouble. So it's so essential that I talk about democratizing the metaverse, as did all of us. Anselm made a clear point at the beginning. That's exactly what has to happen. It has to be owned by the people, not by some company.
Yeah, and yeah. Another question I'm going to take around the panelists is, how can we build this to be accessible to all? What are the key things? And I might start with Daesh again, because there's a wonderful Alan Kay phrase, again, this is how important he is. If you want to predict the future, you should invent the parents. But Daesh actually knows what it means. What are the tools you see that make us, I mean, I'm essentially wanting to reinvent computing to be more useful to humanity and not just be channeled into things, a lot of things that are quite destructive for humanity.
Yeah.
So I don't know, from your on-the-ground experience, you have some?
I like that. If you want to build the future, you have to invent the parents. When I first started TechPlayzone in 2005, and I began the marketing campaign of letting folks know that we were having an after-school program, they said, oh, what are you going to do, karate? No. Dance? No. Sports? No. We're going to do computers. Computers? What do you mean you're going to do computers? My kid would never be interested in that. What do you mean you're going to do robots? My kid would never. My kid is an outdoor kid, Daesh. My kid wants to play sports, Daesh. My kid is not one of those techie, nerdy kids, Daesh. And so we had to change the mindset of what it means to be a developer, what it means to be a technology professional, even for a pre-K student, even as they're playing with their crayons or doing their building blocks or learning their ABCs, they're actually doing computational thinking with that number line that they learn. So every kid is a technology professional in some sense. They have the capacity to be. And so the kids that we are now impacting, thousands of kids around the state of Florida, thousands of kids around the nation, we are now telling those young people, when you're bringing up your own kids, don't limit their possibilities. If they love art, congratulations, they're a graphic designer, and now we need them in the 3D space. If they enjoy reading, then congratulations, reading can be used. All skills can be used. And so we have to sort of change the mindset of parents about what it means to actually have kids who are computational thinkers and who are the designers and the developers and what young people can do. And then on that same note, as far as tools and capabilities, I mean, we've already seen companies such as Autodesk, which is huge, right, for CAD. They came up with Tinkercad. And Tinkercad allows our younger students to get involved with making their own 3D models. And that's what we want industries to think about. How can you take the glasses that you're building today and frame it in such a way that a young person can engage and learn to do the exact same thing that you're doing? So we start with the parents because it's important, and then we're going to invent the parents with the next generation of kids.
Right.
Thank
Cool.
you. I'm going to follow up on that, how will we build this question too, but I just actually, Andrew, wanted to ask you something on the human-machine, human communication, because I know you have a lot of thoughts on this and how, you know, it's more, we have some more fundamental problems to think about when we say we're going to build the Xverse.
Well, yeah, I mean, my role these days as a greybeard is advisory. So we're working with brands at the moment who are all jumping all over the bandwagon of the metaverse. And do we have a solution? And what is that solution? And how does it start? And where do you go? And you have to kind of reverse out that a bit because, pragmatically speaking, it's a term, but it's kind of all-encompassing. And it means everything to everyone at the moment. And you know, I was in the metaverse in the 90s when I first went on the internet. I was in the metaverse when I was using Nike shoes with pedometers in them in the early noughties. I was in the metaverse when I'm, you know, sending messages on my iPhone, whatever. But ostensibly, to be able to be to maintain the function of sense and not be full of hyperbole is the point where I step in. And subject to the experiences with regard to interoperability and standards, the idea of the first language I really learned beyond written English was a musical manuscript that I used to be a performer as a musician. And it was the same manuscript that other performers used to combine, to come together and play a piece of music and to be on the same time signature and to rise and fall at the right points in the music. To my mind, what has to happen to be able to create a metaverse that makes sense, that has interoperability and has a call to action, you need to have some level-headedness and to create the right methodologies. And to my mind, that's quite boring because that's standards. And that's standards. The Victorians were good at standards, you know, what size millimeter nuts and bolts, whether the rails you had on your railway were the right width or not to join together. We kind of have to go one step back and beyond the hyperbole of us all living in a first-person 3D narrative world, in a mirror world. How do we achieve that? Well, it gets down to some of the nuts and bolts of how humans agree things like standards.
Right.
Yeah. And I think that's brought me to one of my favorite, or probably my most central topic of thinking at the moment, and this is, you know, if the real world is going to be the platform for computing, a privatized operating system really is untenable. I'll again ask Anselm to elaborate on that, but I would like us to all start thinking open source is where the XR business thrives. We've mentioned the web. The web is the greatest piece of open software created by mankind, or people-kind. But anyway, Anselm, I'd like you to talk about that because I know you've put a ton of research and a ton of attention to this matter.
Yeah, it's interesting. I was thinking when Dish was commenting earlier, something that you said reminded me of Nani de la Peña's work emblematic on it's kind of augmented journalism. You have somebody who's just trying to tell a story and using a new medium for that. And I wonder if it's possible for her to have airtime and visibility in a place like a walled garden metaverse, right? Or would they censor her or restrict her voice?
Yeah.
And it's kind of, we don't often think about the stakes here, which is that there will be some kind of metaverse, but will that metaverse be one that lets us, almost in a sense, come from the outside and tell stories that may not be entirely proved by the status quo. So for me, I think that it's about, obviously we need standards, and Croquet is doing a very good example of that, but I think it's kind of like there's a mindset to protect the commons and to make sure that if we're working in commercial ventures, that we should have an open source aspect of our work or APIs to access our technology. We should make sure that we could, component-based pieces that can interact with other pieces. Unreal Engine is a good example. It's open source.
Yes.
It has easy to extend. So I guess I would say that as professionals, we kind of have a duty to remember that not everybody is a professional, and we should make sure to make everything accessible to the non-professional communities.
And I think I know David didn't mention this when he talked, but Croquet won the startup competition, pitch competition. And I just want to say that David is also one of the greatest contributors to the open source ecosystem. That this is a world where everyone can be involved with contributing to the ecosystem while they build a business. And that's everyone on this panel proceeds that way. They walk this line of being a contributor to a wider ecosystem and building a business. It's not in conflict if we think this through. I'm confused on time. The clock there says 10 minutes. My clock says 1 minute left.
Well,
have we 10
My
minutes?
clock says we've gone overtime.
Well, I will
No,
leave
speaking
it
us
to the panelists perhaps to just give a last thought down the line and perhaps, and I will say one more thing. We are really, I've been talking to a lot of people at the event this week about this theme of, the Metaverse Live, and, there's several projects, you're all aware of Living Cities Announced, Niantic, the Malta Project. And I think we really, anyone interested in some of these themes you've heard, please contact any one of us, because I think we're going to build this over the next year, some of these themes, and we'll have perhaps a real track on this. And so please ping us. Any other last thoughts if we've gone over? Our clock says we have 9 minutes. So.
We have 9 minutes.
We have 9 minutes. Well.
Can I chime in real fast, Tish?
Sure.
So we were talking about accessibility, and I've talked a lot about software accessibility, but on that same token, we also need hardware accessibility.
Right.
A few years ago, before COVID, we put Chromebooks in every classroom, and we gave ourselves pats on the back and said, look at the great job that we did, giving young people access to digital equipment. And now, as much as I appreciate the Chromebook, there's no possible way I can do an Unreal Engine on there. I can barely do any web-based renderings at all with a Chromebook. And so as we're developing our solutions, or as we're thinking about how we want to engage the underserved, underrepresented groups, or people in other countries, third world nations, we have to think about what types of devices we can create that will allow people to still have that same power to pursue careers in the metaverse, or gain skills in the metaverse.
Absolutely, I agree with that, because the hyperbole of the idea that we're all living in the future is interesting, but there's allegedly 3.2 billion people on the planet who are online. So to avoid it becoming an exclusive place and a class-ridden place, we should be focusing our efforts very much on enabling people who have not got the basic access to even get on the on-ramp, I think.
That's such a, Dave, thank you for raising the open source hardware issue. As, early on, I'm, an OOG or an OG in this space, whichever you like to say.
Yes.
But we had way more open tools early on in this space than we have now. And there's been a closing down of many critical tools. And in the hardware space, the things like the Daydreamer are gone. There are a few around the world. If you look to Finland, Eastern Finland University, I think is our open hardware project. But this is really important. If you're going to have things on your eyes that everyone, you have to have that accessible and open too in some form.
This is exactly right. This is a thing that we're about to embark on as an extraordinarily personal device. And one of the things that there's a huge dichotomy between what we think of as the PC, where we can actually create anything. We can code, we can do, and then the phone today is a consumer device.
Right.
You get what they give you. You can't really, you might be able to edit some videos and stuff, but basically it's designed to feed you stuff and get your responses to that in that feedback loop. This is the worst thing that can happen to humanity, is that the system that we're going to be wearing all day long, every day, becomes a consumer device. It completely devalues what humans are. And this is the not just a challenge, it's a really scary, I think even existential situation. Because on the one hand, we're going to be empowered and ennobled by this next generation, or we're going to become the servants of it. I mean, if you don't think you're not a servant of Facebook, you just don't understand what's going on Facebook. And this is the challenge we see the next generation. Are you going to be the master of that world, or are you going to be the servant of it?
Wow.
Yeah.
I'll live on that one.
That's a hard act to follow, maybe.
As ever, yeah.
Yeah. But I think this is, one of the things that is the absolute central theme for our lives, actually, all of us, is that, and again, open source and open collaboration, they have really, really developed over the years. They're not like, at an early stage. This is a very amazing way for humanity to get together, because all you need to do in open source is to actually agree on what you can agree on and move forward. Then it leaves the whole principle of its public discourse, leaves out all the things you disagree on, and you can move forward. And it is sad that we don't have any sort of significant big effort on the hardware.
Like we had with Scratch, right? We can all sort of think about Scratch, which was developed, and Scratch allowed almost any kid ever that wanted to learn for loops, if statements, conditionals, variables. If you wanted to learn it, it was there. It was easy entry. We call it low entry, high ceiling, right? And that way you can get in and you can learn. We don't have that yet for the Xverse. There isn't one platform, one catalog where you can go and say, I'm going to build my 3D model here, and I'm going to import it. I'm going to give it some rigging so that it can become animated. I'm going to add some code to it so that it can port to another space. That does not exist, and I know it can. Yeah. If we prioritize, I know we can have that.
Yes. And I think there was actually a theme I was going to bring up in the questions, and now we have a little more time. I was lucky enough to work for 4 years with Will Wright, who's the great master simulation designer. And I think that one theme here we're trying to dig into is making the world playable. Will used to say that to us all the time as his team. We are trying to make the world playable. That's what it's about. And I think, I wasn't simulation, distributed sims for everyone to make the world playable is a long topic, but I don't know, I think this theme of making the world playable, anyone want to pick up on it?
I can respond to that.
Yeah.
I think actually there's a role for our technology to help us not just have fun or communicate and have a good time, but to play test the future.
Yeah.
We can try things for real, or close to for real. To really test out our civic engagement communities, intersection with ecosystems, and model the intersection of our land use law and policy, and actually as communities move forward. So the tools aren't just kind of for fun. There's kind of very big table stakes for us because they're decision-making tools. These are tools that governments have and that large corporations have, but we as citizens need to actually be able to put our toys on the table and kind of play test out and try project our future.
Yeah, that's really well put, because I think that's something you and I talk about a lot, is that simulation is how you can play test the future, and it's totally given, really, that power of that tool is totally in the upper hierarchies of society, not where it probably needs to be the people on the ground in the real world in communities.
Yeah. Wikipedia was an example of something that was surprising for me. I think in the future we're going to see something similar that's surprising, something more like a computational soup that we can't really imagine yet.
Exactly.
Yes. Well, I really do think we're coming to the last seconds of our talk, and I think as a final thought, this theme of open collaboration is something everyone in this panel and myself are really committed to, and I think we're really committed also to developing it even further here at this event and other places. So please ping any one of us if it resonates, any of the things we're saying, because that's the most important probably message we can leave. Let's work together on some of this big stuff here. It's actually open source and open collaboration is where business thrives. So
It is where business thrives.
yes. So thank you so much, everyone, just for your work, your lives, for telling us all of the stories of this today. And let's keep doing it, and let's bring more people into this. And
Thanks, Tish.
thank you.
Thanks, Tish.
Thanks, Tish.